Hey guys, this is the Tikz tutorial, and in this video we're gonna make this diagram. As you can see, this is a pendulum and there is some plane and some 3D x, y, z coordinate system. So this is the diagram we're gonna draw in this tutorial. So actually this is the passage from some physics program, and I already typed the program as passage as well as the problems, and now we have to draw this diagram. So I'm gonna use some package here. So first package I'm gonna use is kinematics. Let's comment here. So let me click a space will help you identify what I'm writing. So first package is kinematics, and second package I'm gonna use is Tz or package I'm gonna use. So if you want to download this package, you can use LaTeX or whatever the platform you use for the text platform. So yeah, so firstly from the kinematic text, this is the command I have written for this frame. This is the ceiling of this. As you can see, this is the ceiling, and from that there is a plane at 12 distance. So let's draw a plane, or simply first draw a line. So for line we can use Tz line. Tz line is the command inside the package or Tz plot. So let's Tz line kind of accept two argument, coordinate 1 which is the starting point of the line, and then coordinate 2 which is the end point of the line. So from we have to name this frame. So let's say ceil, CEIL, or say ceiling, and we want a line from ceiling to downward, right? So we have to use relative coordinates. So that's why we're going to use line plus. Represents the relative line between two coordinates. So firstly we're going to say ceiling dash center. Ceiling dash center represent the center of this ceiling, or we can say this frame. So from there we're gonna move downward 2 unit or 3 unit, whatever you want. So let's say we want 0 unit towards left or right, and minus 4 unit towards downward. So after saving, as you can see, this is a line, and from there we're gonna make a plane, horizontal plane at this distance, right? So for plane we can use parallelogram, rectangle, or any geometry you want. So let's draw a parallelogram, right? So what we will do for the parallelogram? So parallelogram, as you can see, from this point to this point, and you can use either absolute coordinate or you can use relative coordinate depending on the scenario, what kind of thing you want. So let's now draw the ground. Firstly draw this pendulum thing, and for that we're going to use again Tz line and then after ellipse. So firstly make a reference in your mind what kind of geometry it required, right? So after observing this diagram, as you can see, this is a path which is in shape of ellipse, right? Which is dashed, right? This is the path of the pendulum, and then after this is the string of the pendulum, right? So first thing we have to draw a ellipse, and ellipse is at distance L because as you can see in the program, the pendulum bob has mass m, the length of the pendulum is L, initially at rest, a particle P, everything is given. So the path is not definitely at L because the length is L, that means somewhat above that means the distance between ceiling and the ellipse will be smaller in compared to L. So let's draw an ellipse. So for again ellipse, you can apply TZ ellipse. TZ ellipse accept two arguments. Firstly, on the center, and then after length, or you can say x dimension and then y dimension. So again we're gonna use the calculation here. So for that we're gonna wind this inside the dollar sign, which represents the calculation of coordinate system. So first coordinate will be like ceiling dash center. Ceiling dash center means this coordinate, and from there we are gonna move downward. So from there we're gonna add something. So let's say 0 comma minus 1.5, and this is not the best idea to do this kind of thing. So for that we can define some dimension. So for let's say capital L will be the length. So let's say capital L is 2 unit, and for that we are gonna 2 times. Firstly we represented directly hard coded value, which is -4, and now we are gonna do something. It's like we defined the value of L, which is 2, and -4 will be like 2 times L. So that's why we did that. And for the ellipse part we're gonna say, let's say 0.7 or 0.75 is okay, and depending on the scenario we can also define the angle, and for that let's define the angle as well. So angle for let's say A is the angle, and angle will be like let's say 30 degree. So we're gonna move is like L, and this is the vertical distance. So L cos theta will be the required. So L and then cos 30. So cos A, this is the coordinate, and this is actually the center of the ellipse. And then after we're going to define the x dimension. So as you can see, x dimension will be L sine theta. So let's say L and sine theta. So for angle you can say angle sine theta, and then after you can say and this is actually the formatting of the command. So we have to kind of get used to about the command input, how the inputs gets into the command. So this is the x, and then after we can say by. So by, depending on the scenario, we can say let's 0.5 for right now, and let's run this. So as you can see, this is the ellipse, but as you can see 0.5 is enough, but as you increase the angle, it will settle down accordingly. You do not have to manually put the value every time. So as you can see, this moves up and down, and for right now let's put 30, and this is like 0.35 will be enough, I guess. So yeah, this is how we're gonna draw. Or if you are feeling like this pendulum is kind of a small, then we can increase the length of this pendulum. Let's from 2.0 to 2.5, and it will like accordingly settle down everything. And so yeah, first part is done, and now let's consider the second part, which is the mass of the pendulum, which will be simply a point. And for that we can use TZ coordinate, and this is the start version of the command. So that's why by start means it will fill the coordinate at that point. So for that we can use what, from ceiling to downward, like L cos and then L sine. So again you have to use the coordinate calculation. So for that, let's firstly calculate the ceiling dash center, and from there we are gonna move like downward then left. So again we have to, for left we can use minus L times sine of theta, that means sine of angle. This is the x coordinate, and then after we can move downward, right? So again minus L, negative represents the downward calculation, right, into cos of theta. So cos of the angle. So this coordinate will represent the this point actually, and we can name this coordinate as well as the define the radius of the dot we're gonna make. So let's call this coordinate bob, 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 metallic bob or something, and let's run this first. You can see this is the mass, and if you want to increase the dimensions, so for that we're going to say 4 point is kind of you can use millimeter, centimeter, anything. So yeah, as you can see the shape is a bit larger, and now we are going to draw a like a dashed line, or you can draw a solid line even. So for that, let's say tz line. This is not the relative coordinate, this is the absolute. So we are going to join the dashed line from the ceiling dot center, dash center, to the bob position. So we're going to say dashed for the dashed line, and then we're going to say ceiling dash center from there to bob. We named this coordinate as bob, that's why we're going to use bob. After saving this, you're going to see a dashed line here. This is fine. And now from there, as you can see, there is a horizontal line. Horizontal line, I don't know why it is horizontal, but I guess I have no idea. So yeah, I think firstly the pendulum is in the horizontal vertical position. There is no kind of rotating thing happening, but after collision, this particle starts to move towards left, and then after again there is another collision which is happening in the z axis, and that's why this pendulum is performing kind of elliptical or circular motion in the xy plane. So, or you can say xz plane here, xz plane. The Bible will be like this. So for that illusion, we have this point like at t is equals to 0, bob is at L, below the ceiling, right? So for that, let's say again we're gonna plot a coordinate. So again we're gonna say tz coordinate, and again we want like solid. So for that we want x to be 0, or we can use coordinate calculation. So firstly ceiling, you can do hard coding as well, it doesn't matter, but for the long term I think naming things, referencing things is the ideal way to do. So from that let's move 0 towards left, right, that is exactly straight, and from there we want L unit downwards, so minus L, and we want to name this thing. So we're going to name bob which is at t is equals to 0. So let's say bob to, that means bob at t0. I know naming things is kind of weird, so let's do that, and then we're going to define 4 point, which is the dimension of the bob. So as you can see, this is the bob at L distance, or L height below the ceiling, and then after we can represent a mass which is moving towards x-axis. We're not going to draw exactly the same. We are describing this scenario in the diagram so that a student will be like comfortable from the reference diagram. So as you can see, there is another mass which is of mass m by 2 moving horizontally along negative axis. That means particle is moving this way, and from there it is colliding from the bob. So again we have to make a coordinate which is called mass m by 2. So again we're gonna use here tz line, and this is relative. So for that, and from we want bob at t0 to like this way, so particle is moving like this. So for that let's say minus 1 comma 0, sorry 1 comma 0, because we want towards right. So yeah, as you can see the particle referencing, as you can see from the diagram, the particle is moving towards this point. And one more thing I'm gonna say, you can make this line little like sideways. So For that we're gonna shift this part. So let's say 0.5 b0. So this is the position shifting for the any command. So you have to write in between the angle bracket. So we shifted this whole arrow thing towards like right. So 0.5 unit, which is the x displacement, and 0 for the y displacement. So this is pretty much standard. So as you can see, this line shifted towards the right. That means the bow is moving towards right, which your mass m/2. And one more thing I have to do is at the end of this point, we are gonna make a small mass which is of radius, I think 3 point or 2 point depending on the scenario. So let's say how you gonna make this bob thing. So let's again tz coordinate, and again a start version. So again we need a coordinate calculation thing. So we're gonna copy this whole thing. That will be better, I guess. So copied whole thing, and we put it like 2 point, let's say 3 point. 3 point will be enough. And one more thing, we have to shift, because originally this point was like here. So we shifted 0.5. That means we have to shift the bow as well. So that's why we're gonna say 0.5, 0, and this will shift the whole like bob. Oh, where I missed the point. I don't know. I think something is not working here. We shifted, but I think something is not right. Oh man, I did something wrong. We have to use bob, right? So we put it the wrong coordinate. Don't worry, we can say bob at t equals to 0, and then after saving no bob t0, and then we have to shift 1 unit towards right. So plus diagonal 1, 0, and then again yeah, it will be fine, I guess. So yeah, so this is the mass moving towards negative x-axis, and which is colliding with this particle, and then after this will move towards this, and then again this another mass is colliding in the z dimension. That's why this is performing the kind of pendulum thing. And one more thing, we drawn the ellipse, and which is in the dashed version, will all look great, I think. So dashed version. By the way, you can put optional keyword argument inside the square bracket. So as you can see, this is dashed version of the bob's path, which is elliptical we are appearing, but actually it's circular. We're gonna see from the above, and this is how we will see as a circle, but from the sideways we're gonna see the ellipse form. So that's why we drawn as ellipse. One more thing, let's check firstly. So if you change the angle, the whole pendulum will shift upward, right? And the point we drawn is fixed in the same place, because initially at t equals to 0, the mass is exactly at the L distance below the ceiling. So no problem here. We can actually change the angle to 40, I guess. That will be a little like shifter, yeah. So this is fine, I guess. And one more thing I have to do, we have to represent this kind of distance as a 12. For that we are gonna say on tz line, which is again relative coordinate, and again we are going to do some calculation. Again the coordinate which you required, often we can save that part as a reference point. So like we are using ceiling dead center like again and again, so we can define that part as a coordinate. So let's say tz coordinates define. So this is where we're going to define as non-start version, because we don't want the dot point, right? So we're going to say ceiling dash center. We can put this, let's say ceiling dash center, and double parenthesis will be wrong, ceiling dash center as O, which will be like O simply. And for referencing this O, let's firstly run this. It will change nothing, just be referenced on this part. I think something is wrong. Where is wrong? tz, yeah, tz coordinate be referenced O, no problem. where's because so we have to comment this line and then we have to run this parts. So as you can see, there's no change in the diagram, but now we can reference this O as ceiling dash center. So we don't have to write like all the long ceiling dash center, ceiling dash center. So we're gonna just use dash. So yeah, you can change all the ceiling dash center in a single command, but I'm gonna do manually. So wherever we use ceiling dash center, we can reference that point as O. So now it's exactly the same diagram, but a little kind of convenience to use the O coordinate. And let's draw the vertical line, which is this part 12. So for that we're gonna say O. From O we're gonna move towards right. So we're gonna move a like 2 unit. So 2, 0 will be fine. And from there we're gonna move downward, right? So 0 x, we don't want x to be shifted, right? And we're gonna like minus 2 unit downward. So there will be a line, as you can see. So this is the line, but the problem with this line is it's like no arrow kind of things. For that we can use optional thing. So dash means this will make this part, angle bracket means arrow thing, dash means line, again angle means other end पे भी ऐसा ही रहेगा, and then again we can make this part. So as you can see, this line is like this reference line, and we want some level as well, which is 2L. So 2L, and we want midway right. That means in the middle of line towards right side we want this level 2L. So after saving it will be fine, I guess. So as you can see, this is the 2L, perfectly fine. And one more dimension we're going to describe exactly on the same way. So we just have to copy and paste, and this time we're going to say minus L. But the problem with that is we want towards left side. So let's say where is wrong? Minus L, and this will be L. So as you can see L, but this time we want left. So yeah, as you can see, pendulum initially was at L height, and then after a rotating part happening, and then after it is like shifted upward. So yeah, this is how we're gonna make this a diagram. And if you're thinking that why putting this part towards left, so you can put towards right depending on the scenario. So let's put the right part. So 2.5 will be enough, I guess. And this will be right, and 2.5 is not enough. Let's 2.75. So yeah, this is okay, I guess. And so I think most of the part is done now. And one more thing we're gonna do is make the coordinate system and a plane. So for that we're gonna use like coordinate system is shifted like towards right. So for that we're gonna use scope, actually scope. And what a scope does is like a whole code will shift towards right or left depending on the scenario. So let's draw this coordinate system. For that we're gonna do TZ coordinate system. So let's say TZ axis. Actually TZ axis is a command within the TZ plot. So TZ axis, and we're going to reference the starting coordinate, and then how much length we want along x. So let's say 1, 1, 1. So this is like xyz. So after saving we're going to see a but as you can see it drawn at the 0. So we want to shift whole system towards right. So we're going to say x shift is equals to, let's say, 3 centimeter. After saving it will shift, yes, whole coordinate towards right. And let's say 4 unit, 4, and by shift as well. Y shift is equals to minus 2 centimeter. That will be like move towards downward. So yeah, this is the coordinate, but as you can see z is not representing here. So we're gonna like use the like Tikz here, not the TZ plot, because TZ plot is only valid in 2D plane. So we're gonna delete this part, and we can reference this as x-axis, then reference this as y-axis. After saving, we will see xy, right? And one more thing, we have to draw z-axis. So for that, let's say draw is like Tikz command, which is the fundamental package for drawing diagrams inside the LaTeX. So draw, again we want from 0, 0 towards we want inward. That means again 0 will be x, but z will be -1, right? And original Tikz command always ends with the semicolon, so you have to careful. So after saving this command, as oh no, nothing happening. Why? Let's save this. Nothing happening. What is the matter? Oh, sorry, we missed the dash part because I'm used to TZ plots, so that's why messing thing up. So original Tikz command is like manually you have to put multiple thing. So for line you have to put double dash in between the coordinates. So yeah, as you can see, it is representing the z axis, and we can put the node here. So for node, we can use node, and then we can put z. But node, we're gonna say let's say right. So yeah, as you can see, z axis towards inward. And if you want like longer z axis, we can use 1.5, and then say dashed part will be better. So yeah, this is it, but I don't think dash is required here. We want solid lines. So yeah, this is the reference line here, and we can use as g towards downward depending on the scenario. But do we want that? No. Let's draw a jet, which is this part, which is gravity acting towards the y-axis. So for that, we're gonna use TZ line, actually TZ line, which is standard TZ plot command. So for that, we are gonna use x will be -1, y will be 1, and from there let's put this as a relative coordinate, and then after we want 0 xy, no movement towards x, just we want -1, and then after we're gonna put a node here. So for node g, we want midway left. So as you can see, one more thing, I have to put the arrow, and -1 is not okay, I guess. So let's say 0. No, -0.5 will be okay, I guess. Yeah, g is like that. Let's say -0.25, which is kind of closer towards the coordinate system. Yeah, so it's fine. As you can see, after zooming in, as you can see, diagram is pretty okay, I guess. And you can shift depending on the diagram what you want. It's the personal preference how you want the diagram to be look. So yeah, as you can see, this is the perfect. And one more thing we have to do is we have to make this plane thing, which is kind of difficult in 2D plane, but we can make this, it doesn't matter. So one more idea I have to apply here. If you want some 3D diagram kind of thing, we can use original Tikz package, which is of course great for plotting 3D diagram. But here we want like 2D, not 3D kind of thing. So for that, let's draw a rectangle. So let's draw. We're gonna start from like this part, which is always going to use. Let's use. So actually there is a website you can use for referencing. So Tikz.net. Oh sorry, I don't have the network here. Let's connect. Tikz. No topic, I don't know. Yeah, it was the, let's say 3D. Yeah, 3D coordinate. As you can see, this is the 3D coordinate system, and you can use this as a reference, and it will be much better. So this is actually the graph part. We don't want graph, we want, I forgot actually what is the website for that. Takes 3D, yeah, 3D rectangle, plane x, which plane we are gonna make, let's say xz. So which website I was talking about, actually I forget. There was a website in which the documentation was perfect. Tikz.dev, yeah, this was the website I was talking about. Yeah, this was the website. So as you can see on 3D plotting, layering, technical, where is the, not 3D plot we want. I don't remember exactly. Let's take Tikz.dev, that will be much better. And graph drawing, let's say go to Tikz and then graph drawing, no, libraries, utilities, basic layer. I actually forget how to make. Let's ask ChatGPT. So I'm gonna ask ChatGPT to I want to draw a rectangular plane in xz plane 4 unit below the center below. Yeah, so this will help. Actually Copilot is not that great in text. I tried multiple times, but here it is fine. Yeah, so let's paste this code and let's run for right now. So as you can see, this perfectly drawn a rectangle. And one more thing we have to do is remove this draw part, and we don't want any fill kind of thing. And let's say -4 unit. Yeah, for that it will reference. And we don't want any fill, right? So we are gonna just remove all these optional part, so that will be just a rectangle. 4 times, sorry, 4 times, 2 times L, right? 2 times L. So it will shift towards right. Yeah, as you can see, it drawn a perfect rectangle, as you can see in the x z plane. So yeah, you can take help from the GDP, which is great, by the way. And I think this diagram is done here. And you can do multiple things, fill this rectangle also. Let's try to fill this. So pattern is equals to northeast lines, and it yeah, as you can see, this command fills the geometry, or you can say close geometry, in a particular manner, which whatever pattern you gonna define, it will fill the geometry. So yeah, this is the plane, and this is how you're gonna draw this diagram. And I think nothing much here to do. By the way, you can increase the length of the frame, which is kind of short. So let's increase to 5, I guess 5 will be fine. So yeah, this is fine. And let's see in 100%. Let's close this, and then you can see this diagram is perfect. Kind of look weird because the plane, is like too much. Why is it okay? I don't know. So after that, let's keep this as it is. And by the way, you can if you want the diagram to be exactly center and this kind of coordinate reference thing to be right, then you can do that. But I think it's okay here. But I'm gonna do some thing. 12 is which pretty large, so we're gonna say 1.8 and this is 1.8, so that this plane will look kind of concise. So yeah, now it's fine, I guess. And one more thing, 1.8 not 2. So pretty much it about this diagram. I hope you learned something from this tutorial. By the way, the more you use the Tikz, I guess you will better become. It's like it's a practice kind of thing. You're not gonna like become like a better drawing maker in a single day or two. You just have to use and use and use continuously. And one more thing we can do is level the mass of the bob. But we're not going to level here because according to the question some collision happening, and after collision some mass gonna change, the sticking thing happening. So we're not gonna level anything. So let's keep it this way, simple. Or yeah, this part we're gonna reference as under 2gel because we not need the reference or not, because already in the paragraph defined everything properly. So yeah, this is it for this tutorial. Thank you, and see you in the next one. And in the next tutorial I'm gonna make this diagram. Let me show you which diagram I'm gonna make. So this is the diagram I'm gonna make in the next tutorial. This is quite simple, as you can see. It's pretty trivial diagram, so you can make yourself for the practice. And I would say do not make others diagram. Like if you find something useful in your daily life, it's like if you're a physics teacher or a maths teacher or chemistry teacher, draw accordingly. It's like you won't find interesting in this diagram because you don't need this diagram. So if you need some kind of mechanical system, let's say you want some STM thing going on and want some block platform and a spring, then you wanna make that diagram, and for that you can start Google thing and then go through some tutorial, basic fundamental thing, and then you will find interesting. Like in this diagram you won't find anything interesting, but I need this diagram. You don't need this diagram to be like look like this. So yeah, thank you, and see you in the next tutorial probably.